I'm going to try and explain what occurs with the tilting of the base of a grinder or offsetting it forward and back. So there's a few key things we need to know. First off, I'm the last person in the world that should be explaining this. Chain grinding is not my thing. The next thing we need to know. I'm using an ABN wheel. This works the same if you have a stone wheel. The reason for profiling the wheel is putting in that radius on the edge of the wheel. The intention is you use that radius on the edge of the wheel to form the cutter profile. So why people aren't seeing results with this is due to the wheel depth. So I'll try and show that. So what most people do, and I'll zoom in on this, is when they adjust the height of the grinding wheel, they come down and lower the wheel until it's into the gullet, into the lower section. Now, the important thing to remember with chains, any chain that you're using, the last thing in the world that matters is the fucking gullet. It does nothing. So ignore the gullet. Forget it. It's pointless. It's not doing anything at all for us. How you should be adjusting your wheel height is adjust it so you're forming the outer edge. You want to be forming the outer edge of the cutter using the radius that's on the edge of the wheel. So that radius that you've formed into your wheel, you want to use that to form the outer edge of your top plate. So its actual height is going to come in something more in line with that. Ignore the bottom. It is irrelevant. All right, so the next section of this, if you look at the tilt angle, according to Stihl, they want you to end up with a 50-degree angle. In the USG chart, it's described as plus 40. On an Oregon, that would be 50 degrees. They tell you to come down at that 50 degree or 40, depending on which grinder you're using. And they tell you in the end of the specification chart that they're looking for a 60-degree side plate angle, the angle coming down the side. Now, if you're bringing the wheel down and forming that outer edge with the flat section of the side of the wheel, you're going to end up with a 50-degree side plate angle, no matter how you tilt this. No matter how you adjust the slide at the bottom or you tilt on an Oregon base, if you're using the flat side section of the wheel to form the outer part of the corner, the upper part of the side plate and the top plate, you are going to have a 50-degree angle there. There's no escaping that fact. So how do they give us that 50-degree description but tell us to end up with a 60-degree side plate? That's because they want us to form it with the radius part of the wheel. That is why they tell us to radius the wheels. I can't radius this. It's an ABN wheel. I'm stuck with what they gave me, but I'll show you how to make it work. If you're using a stone wheel, just set the radius to whatever's recommended. Use the radius to form the angle that you want. All right, let's try and show the differences here. Base is set at 0 degrees. My angle coming in is at 50 degrees. I'm going to adjust the height how normally people do it, where I'm trying to form this outer corner with the flat section of the wheel, and we'll go from there. All right, that's good enough for our purpose of comparison here. The angle that we've ended up there with is 50 degrees because the wheel is coming in at 50 and we're using the flat section on the side to form it. What can we do to make that different? Well, the first thing we're going to do is raise that wheel up. 10-degree tilt on the base, 50 degrees coming down. We're going to be forming the corner with the radius part of the wheel again. And then once I'm done with all of this, we can compare them and you can look and see what the difference is. So we have cutter number 1. This was done with no tilt, head at 50, and with the grinding wheel touching the bottom. and we can see how much side plate angle there is on that. It's a lot. If you look back here at the witness mark of what they recommend and what we've actually achieved, that's not good. This is the last one I did. This was using both some tilt on the base and forming it with the radius part of the wheel. That's how I usually grind them. So anyway, back to what I said in the beginning. I'm the least qualified person in the world to talk about this. I really don't grind that often. But the basics of it, if you're using the flat section of the wheel to form the upper section of that tooth, so about the thickness of the top plate coming down the side, tilting it will show absolutely no difference. It's just how it is. However, if you are using the radius section, you can adjust where that radius sits and you can modify it. So you can end up with the correct shape in the outside of the side plate, as well as having the inside of the wheel low enough to form the correct top plate cutting angle across the inside. That's what the tilt's really there for. When we tilt that base, it is essentially lowering the wheel down further through the inside of that cutter. The entire point of tilting or sliding the base is to allow more of the wheel to go deeper down on the inside edge of that cutter. If we're doing it on this side, we obviously tilt it the other way and it extends further down through the inside of the top plate. So what it allows you to do, it allows you to end up with more top plate cutting angle out here on the outside or the inside of the top plate, while reducing the side plate angle on the outside of the cutter. This is exactly what we do when we tilt a file when you're sharpening. So that base just allows you to do that with a grinder. But if you're using the flat section of the grinding wheel up the side of the wheel to form that upper section, it will not make a difference. I don't know if this is any clearer for anyone. Like I said, I'm not the best guy to explain this, but that's generally how it works.